In this video we are analyzing the structure of Bonnie Parker's hard drive that we downloaded in previous homework assignment 820, and in laboratory B22 we will be navigating this hard drive using FTK Imager and WinHex forensics. So make sure that you download and install WinHex tool from Xways Forensics, and this link right here has a licensed version of WinHex with specialist license. You will see it shortly. And as you download the zip file, just unzip it. It will create a folder like this and run the setup program. Okay, after installing WinHex 15.0 with the specialist license, this is how it looks like, and we will come back here later in the second part of our lab. Occasionally, we will also use this handout right here, file system data structures, which we can use as a reference. But to begin, let's switch over to FTK Imager. So just start FTK Imager if you haven't started it yet, and add Bonnie Parker's hard drive image as evidence. So select image file, and after downloading this zip file, I saved it in one of my folders under forensic images, and I just extracted this bparker.001. So this is DD raw format. That's roughly 2 gigabytes in size. So this is my path to the location of the image file, and now I can specify this location. Click browse and select .001 file. You can actually delete the zip file because you really don't need it after you extracted the image from the zip file. So let's open the homework handout, laboratory B22, and I also copied acquisition hashes from the previous homework handout. So here let's run our quick verification, verify drive image. So this will simply compute these values, of course, inside the FTK Imager, and you can see just visually that these values match pretty well. And of course we can copy and paste these values into our forensic reports as we need to. So I have a good match, so that's okay to continue our work. So first, what we see here in FTK Imager, just after adding the evidence file, this properties panel. By the way, if you're not seeing it, just make sure that you say view and display the properties and everything else that you'd like to make visible. So what you see here is bytes per sector, sector count on the entire hard drive, and this is a raw type image, just bit by bit copy of the original drive. So this information, bytes per sector and sector count, is coming from the first sector on the drive, and that's the master boot record. So let's click on partition 1, which is one of the partitions that is available here, and as we begin to look at its properties, the starting sector is 63, so I'll just place this right here, and the sector count is this number, so this is basically our last sector information. Let's expand to the next level. Under this partition 1, it shows no name NTFS, and NTFS file system is typically required by the operating system. So let's click NTFS, which brings us to the next level, and this is where we get our cluster size and the cluster count and free cluster count. So this is all the information which we may need. The dirty flag, of course, specifies whether NTFS hard drive has been updated, but the updates have not finished correctly. So I'm just going to, oops, this is false. So I'm just going to change that. Okay, false. Okay, very good. Then we have the volume serial number. Okay, so that's our next value right here that shows up, and in file allocation table FAT file systems and on NTFS. Volume serial number is a feature used to determine if a disk is present in drive or not, and to detect if it has exchanged with another drive. So this identification system was used pretty long time ago, and it predates MS-DOS. So the volume serial number is a 32-bit number determined by the date and time on the computer clock at the time when the disk was formatted, when this disk was created. So that's pretty good to know, so we can save this information. So we also get our file system version, so we'll just copy and save this one. And then, of course, whether UTC timestamps are being used, so the value here is true. So we just select true on this part of our handout. And the meaning of the true UTC timestamps, it's that we can change the time zone on the system, and the data and the date and time will display the accurate information in any time zone. So this is a feature of the file system to keep timestamps saved on the drive independent of the local time and local time zone. So let's now also look at the recovered partition right here. So this is the second partition that we have here. And once again, we have the starting sector, which is good to know where that is. And we have the sector count, also specified by FTK Imager as we look at the partition properties. Now I'm expanding the tree one more level, and we see my stuff FAT32 volume. So let's click on this. Okay, and we get here we get our cluster size used on this file allocation table file system. How many clusters? We get this too. Free cluster count. Actually, I don't have this field right here. Volume label is available. Okay, so that's something that file allocation table file system was formatted with this volume label. And again, the serial number that we discussed also available. And due to the nature of this file allocation table file system, the timestamps is false, right? So we specify false, which means that we don't have an independent time zone of the local time setting on the system. So really, when we produce our reports, setting the correct time zone for this drive to the best of our knowledge is pretty critical, so that we can display proper times as we would like to see them, as the users of the computer would see them. And in the file list panel, we get the root directory, we get two file allocation tables, file system Slack, and volume boot sector describing the parameters that we obtain here in FAT32 properties. So this information is coming from the volume boot record or boot sector of this file system.